Right, next question. Right, so we are asked now to write down the values of x, right, for which log base 2 of x is less than or equal to 0. Okay, so less than or equal to 0, we know that we are looking for where this function values, or the values of y, right, we're looking for where those are negative or equal to 0. Okay, so negative on our Cartesian plane, right? So if we're looking for negative y values, these are negative y values, right? So these are negative y values, right? Means that we're looking for where is the graph below the x-axis, right? And this part equal to 0, well, y is equals to 0 over there, right? That's the only place where it's equals to 0, right? So that just means that we need to include that value, right, at the origin. So we are looking for where is this graph log base 2 of x, right, below the x-axis and also intersecting the origin. Okay, so now let's sketch the graph of log base 2 of x very quickly, right? Now the base of this log, right, is a 2, right? So that's a value greater than 1, right? So our base is greater than 1, right? So which means that we have an increasing logarithm, right? If you can't remember what an increasing logarithm looks like, it's just a reflection of an increasing exponential, right? So an increasing exponential looks like this, right? It has it's sitting on the negative x-axis, right? And it would look like that, right? For this specific one, this would be 2 to the x, right? I'm trying to do it in a dotted form because it's not what we're trying to sketch right now. Okay, now when you reflect this about the line y is equals to x, right, so you reflect it about the origin, okay, sorry about that, I meant so you reflect it about the line y is equals to x. Okay, when you reflect it, then it's going to come over to this side, right? So it's now going to have or sit on the negative y-axis like that, and then it's going to taper off like that. Okay, so this is log base 2 of x, right? So this is what an increasing logarithmic function looks like. Okay, and we know that this point, okay, is the point 1, 0. Okay, so now we can see very clearly where is the graph below the x-axis, right? It's below the x-axis, sorry, for all of these values of x, right, that are less than 1 but not equals to 0. Okay, so remember that this line, right, x is equals to 0. This is an asymptote, right, a vertical asymptote for our logarithmic function. Okay, right, so for all of these x values in between, right, and we are going to have to include this x value of 1, right, because we are looking for where is this also equal to 0, right? We know it's equals to 0 there at that x value of 1. Okay, so for all of these x values in between here, right, so basically we're looking at the graph in this stage. We're looking at this part of the graph. So we can write that down, right? So log base 2 of x is let me write it in words, less than or equal to 0 for all, okay, x values, right? Let's start just with the inequalities. We'll add the equal signs now, right? So for all x values greater than 0, right? So greater than 0, right? But less than this x value here at 1, right? Because beyond that, we now go above the x-axis, okay? So less than a value of 1, right? Now let's think about the equal signs, right? Can we put an equal sign over here, right? So are we talking about x being equal to 0? No, we're not talking about x being equal to 0, because that x is equal to 0 is a vertical asymptote, right? So we're not going to put an equal sign over there, but we can put an equal sign here at 1, right? Because we are talking about x being equal to 1, because that's where our function is equals to 0, right? Since we are looking for the condition of it being less than 0, in other words negative, or equal to 0. Okay, so that would be your solution in interval notation. Okay, no, this is your solution in inequality form, right? If you wanted in interval notation, okay, then you would state that x, right, is an element of open bracket, because you don't have an equal sign over there, it's not included. The value is 0, right, up until the value of 1, okay, and the 1 is included. Okay. Which other notation do they have again? You can also use a notation called set builder notation. Okay, and over here you use these fancy brackets, right? And you say x, right, such that, and then you put this in, okay, x greater than 0 but less than or equal to 1. Okay, so this is just different formats of writing down your answer. All right.